Welcome to EDU World Space.
Problem 3.122. In this problem, we have to find the value of theta for which there is no moment in y direction at point C, because the valve at point C should not move in vertical. It means that there should not be any moment at point C in the direction of y. So first we will resolve these forces into its horizontal and vertical component and shift them to their corresponding points. That is, we will shift this 40 lb force to the point A and find an equivalent force couple system. Similarly, this 40 lb force will be shifted at point B in an equivalent force couple system, and then we will calculate total moment about point C. So one may think that why we are converting these forces into its equivalent force system at point A and B. Then it is very easy to calculate moment about point A and B for their corresponding forces. So this is basically going to reduce our effort to calculate total moment about point C. So what we are going to do, that first we will resolve these forces. So this is 40 lb, this angle is theta, so this angle will also be theta. So this component will be 40 on cos theta, and obviously this is in negative x-axis, so this will have minus I cap, and this is vertically downward, so this will be 40 pound sine theta minus j cap. This is already along the positive x-axis, so this will be 40 lb I cap. So we can write here the total reaction force acting on the system as R is equals to 40 cos theta and with negative sign, because since it has a minus I cap component, and plus 40, this will be the total coefficient of I cap, and there is only one component of forces in the y direction, so it will be 40 sine theta j cap minus j cap. So we can use here directly negative sign, so this will be minus j cap. So this is the equivalent force that is acting at point C. Now for the equivalent moment calculation, we can write it moment about point C. It will be moment about point A plus moment about point B plus moment about point C, due to those forces that is present at point A and B in equivalent system. So we can do one more thing, that we can directly write it as position vector of point A with respect to C multiplied by the forces present on the point A. The forces are minus 40 cos theta I cap and minus 40 sin theta j cap. And the second thing, that position vector of point B with respect to C multiplied by the force. There only one force is at point B, so we can write it as minus 40 I cap. So we can calculate all those moments. So moment about point A will be minus, so this will be in counterclockwise direction and it is in positive z axis, so it will have plus 40 multiplied by 10 k cap. Now this 40 lb is going to cause a couple about point B in, we can use the right hand thumb rule, and it will give the negative z direction, so it will be minus 40 into 10 k cap. Now we will write the position vector of point A with respect to C, since they have only variation in their z component, since their height and x coordinates are same, so their position vector will be 15 k cap, 15 k cap cross product with the force vector, that is minus 40 cos theta I cap minus 40 sine theta j cap, and the moment due to the force present at point B will be this will be plus 40, first of all we will write the position vector. So position vector is 7.5 k cap multiplied with plus 40 I cap. Now these two are same and with opposite signs, so they can directly be cancelled out. Both are in k cap direction. So now we have to solve these two. So for this we can use this circle, which will help us in determining the direction. So this will be the circle, and where this will be I cap, this is j cap, and this is k cap. So first we multiply 15 I cap with minus 40 cos theta I cap. So 15 first of all k cap cross I cap, k cross I both are in same direction, so they will give j cap, and 15 into minus 40 cos theta will give minus 600 cos theta. So this will be the coefficient of j cap. Now multiplying the second term, so it will be k cap cross j cap. K cap cross j cap is in opposite direction to the counterclockwise circle given. So it will be minus I cap. So it will be minus I cap. Now talking about the coefficient, so 15 multiplied by 40 sine theta, it will give 600 sine theta. Here the sign is negative, so we will use negative sign here. And now the last term that is to be multiplied is k cross I. K cross I is in same direction here in this circle, so this will give j cap. So plus we can directly multiply it and it will give 300 j cap. Now solving now collecting the coefficient of I cap and j cap. So this will be I cap, since there is only one component in I cap, so this is 600 sine theta I cap, and two component in j cap, so this will be plus 300 minus 600 cos theta j cap. Now in the problem we have to find the value of theta for which there is no moment in j cap. It means that this component should be 0. So 300 minus 600 cos theta should be 0. So cos theta should be 300 by 600, that is half. Hence we can say that theta comes out to be 60 degree. So this was the answer of the first part. In second part, this was the first part. In second part, they are asking about the equivalent force couple system at point C. So we have already written the equivalent force here. The first statement was minus 40 cos theta plus 40 I cap and minus 40 sine theta j cap. So we can put the value of theta that we have calculated here. So it was minus 40 cos theta plus 40 I cap and minus 40 sine theta j cap. Now putting the value of theta equals to 60 degree, this comes out to be 20 I cap, 20 pound I cap, and minus 34.641 pound j cap. And the net moment, since there will be one moment component also, we can see here that this moment component in the j cap has already been vanished at the value of theta equals to 60 degrees. So the only component that will be on that of moment will be in I cap, and that will be 600 sine theta I cap. Putting the value of theta equals to 60 degrees, this comes out to be 520 pound inch I cap. So this is the answer.